Welcome into the second NAT lab. In this lab, we're going to configure and verify Dynamic NAT. Dynamic NAT is a little more complex than the straight-up static NAT that we did in the last lab. It involves access control lists. You remember we talked about ACLs and how they're used for more than just controlling access. Well, in this case, we're going to use ACLs to determine what IP addresses can actually get a Dynamic NAT address. Now, this is not the port address translation or the overloading that we talked about where multiple internal hosts can use the same external IP address. We'll cover that in the next lab. So I've backed out all of our configurations on the NAT router except for the IPNAT inside and the IPNAT outside. I figured there was really no point in showing you those commands again. And so just as proof, I'll do show, run, and do include NAT. And the only commands we have that have the word NAT in them are IPNAT outside, IPNAT inside. Prove there's nothing up my sleeve, I'll go over to the client and I'll ping 100.50.25.1. And you'll notice that all of my requests time out because I no longer have that static translation in the NAT router. Or more accurately, the traffic gets to the NAT router, but it says the destination is 192.168.1.1, and I've purposely not put a static route or a default route in my internet router, so it doesn't know how to get back to that network. If I put a default route in there, then obviously it would work because this is just a router in the middle of this, but the internet doesn't have a route back into your internal network, so neither should my internet. All one router of it. So the first thing we're going to do is define a pool of addresses that can be used on our outside interface to do this Dynamic NAT. Now normally what IP addresses you can use would be dictated by your internet provider. In our case, since this is all a closed network, I can use whatever addresses I want. So I'm going to use 100.50.25.100 through 105, which allows us 6 IP addresses. So I'll go to the NAT router and go into the config mode. We're going to do IPNAT pool. We have to give the pool a name. In this case, we'll do public IPs. And we're going to start it at IP address 100.50.25.100. And we're going to end it at 100.50.25.105, and we're required to specify either the net mask or the prefix length for our outside interface. In this case, I'll do prefix length 24, since this is a Class C network mask that I'm using on my internet segment. After that, we can specify the type if we like, match host or rotary. Match host essentially means if you have an inside IP address of 192.168.1.10, it's going to try to NAT out using an IP address of 100.50.25.10, which makes for a pretty logical way of doing your dynamic NATs. The default is rotary, which is you take the next available translation that's not currently in use and you assign that to the pool. In this case, we're not going to specify a type. We'll hit enter. So now we have a range of 6 public IPs that we can use for our address translations. Next, we're going to configure an access control list that defines what IPs can actually get out to the internet. So we're going to do IP access list. Since all we're filtering on is the source address, all we have to use is a standard access list. Now again, if you wanted to get very, very specific about what hosts are allowed out to what services on the internet, you can use an extended one. But in our case, we'll just do a standard. And we'll give it an access list number of 50. For this access list, we're essentially going to permit everything inside of our network because it's all just one Class C network. So we'll do 10 permit the address if 192.168, let's make sure it's a .1, 192.168.1.0, with the wildcard bits of 0.0.0.255. And remember, your wildcard bits are the inverse of the subnet mask. You can log matches against this entry in the local system log if you want. That's what that log keyword does. We're not going to do that. So now we've got our access list set up. Since we're not using it for filtering, we don't have to have a permit all at the bottom of it. If we did have a permit all, then it would allow anything through, and in fact that would be a valid way of natting anything that's on the inside network out through this NAT pool. We've set up our access control list that permits anything in the 192.168.1.0/24 network. Now let's put the two together and validate that it works. This command is very similar to the one we used for the static NAT. We're going to do IP NAT. We are coming from the inside, and our source, instead of being an IP address, we're going to specify an access list describing our local addresses. So we'll do list, and if we gave it a name, we could use the name. In this case, we just gave it a number of 50, and we're going to send it out through pool public IPs. That's all we need for now, so we'll hit enter, and now we have NAT. So let's go over to our client and let's ping this internet address. So we'll do ping 100.50.25.1. We received the ICMPs back. Hey, we were 80% successful this time. The internet host shows that it sent it back to 100.50.25.100, which is the first address in our pool. So our NAT worked as expected. We can actually do show IP NAT translations, and we can actually see that 100.50.25.100 was assigned to 192.168.1.1. Now let's go over to our client and let's do an extended ping and ping from this secondary address that I've got configured, this 192.168.1.2. You probably noticed that and wondered what it was for. Exactly this. So we'll do ping IP, the target IP address is 100.50.25.1. Repeat count 5. We're going to do yes to extended command source IP address 192.168.1.2 and leave all of the rest of them the defaults. In this case, we only have a 60% failure rate, or 60% success rate, I should say. We look on the internet router. We look that the destination is .101. Look on the NAT router. Run show IP NAT translations. You now see that 100.50.25.101 is assigned to 192.168.1.2. Now, after a short period of inactivity, these NATs will eventually time out. However, if you have a large inside network and a small pool on the outside, you may overrun your NAT pool, in which case you can do clear IP NAT translations, and you can just do star for all the dynamic translations. We won't do that because there's one other command we need to run, and that is show IP NAT statistics. In this case, we have total active translations are 2. Tells us what our outside interface is, our inside interface is. It tells us what IPs in our pool are being used. It says we've got 6 addresses allocated. We've got 2 in use, using 33% of the addresses. And it tells us if we have had a request for an address out of the pool that the pool could not fulfill because it's out of addresses. And so now you have seen how to do a dynamic NAT. Stay tuned for the next lab where we do dynamic NAT overload.